I have been writing about how to build teams to work on process understanding, predictive understanding, predictions, and I was even leading a project on Earth system prediction and so on. So, country like India needs its climate scientists to work together on these things because it's a developing country, limited resources, climate community is not that large, and we don't need to focus so much on just blue sky research that has no application right now. It's intellectually very interesting, but what is best for the country? So I'm going to use this paper from the US titled Epic as a catalyst for NOAA's future Earth prediction system. So NOAA is the National Oceanic and Atmospheric Administration, which sits in the Department of Commerce for some historical reasons. Was started during Nixon's time, and Louis Uccellini was the head of the National Centers for Environmental Prediction and various other positions. He's retired now. I think Richard Spinrad is the new head of NOAA, if I'm not mistaken, and so on and so forth. So it's a good team. Bill LaPenta was also ahead of the modeling center and so on and so forth. So what's the abstract? NOAA has launched the Earth Prediction Innovation Center. So EPIC, a bit of a made-up name, but nonetheless, this is in partnership with Weather Enterprise, so academia, government, and industry, to bring the power of distributed innovation to bear on one of the greatest challenges of our time. EPIC provides a collaborative framework building upon the Community-Driven Unified Forecast System (UFS) to accelerate the innovative improvements to the nation's forecast system in order to save lives, protect property, and enhance the economy. This article describes NOAA's strategic, tactical, and organizational approaches to utilize EPIC to transform the world-leading U.S. national forecast system into an even stronger and more effective community-based, computationally advanced Earth system prediction or Earth prediction system. I'm used to doing Earth system predictions, regional Earth system predictions, and everybody uses Earth system, but here they have flipped it saying Earth prediction system to meet the expanding and pressing needs of national and international societies. Now, there's always a competition between US prediction system and the European Unions and others, and in the US many people keep complaining that ECMWF is always doing better than NOAA and so on and so forth. So and then NOAA says because we are not getting as many computational resources as ECMWF can get, and so on and so forth. That's why those things are mentioned here as well. Okay, so this is a long paper. I'm going to just take a few key points and be brief as usual, but I'll show all the nice figures they have. Mainly the point the reason I have in mind for doing this is to see if other countries can also get motivated by building by this paper, this concept, this framework to build teams. As it said here, academia, government, and industry. Even in the US, there was something called climate testbed where the academic researchers were supposed to help NOAA improve its prediction systems, but operational systems are built. They have to be frozen for a couple of years because you cannot keep changing them forever. And so there are lots of issues on how this partnership can work, how quickly research can translate to improved forecasts, and people again complain that ECMWF has a much better interface with the researchers and so on. So these are issues that everybody will face. The National Oceanic and Atmospheric Administration is responsible for producing world-leading observations, information, forecasts, and warnings to protect life and property and enhance nation's economy. NOAA's National Weather Service (NWS) and its predecessor organizations have been meeting this mission successfully for over 150 years. So it started a while ago. Increasing vulnerability to extreme events caused by climate change and socio-economic insecurity has escalated the demand for reliable weather, water, and climate services. Okay, so there are some numbers here. This has led to introduction of Information Decision Support Services IDSS to NWS responsibilities. The US economy has encountered nearly 2 trillion in weather-related costs since 1980. 2 trillion US dollars, with 95 billion dollars of those in damage occurring in 2020 alone, shattering the previous annual record that was set before. But 2023-24 have been record-setting years as well, even though the hurricane forecast hasn't worked out. So the costs of severe weather events are escalating in the United States due to a combination of increasing exposure of assets in weather-prone regions. So it's not just increase in extreme events, but people are putting themselves in the paths of extreme events, and aging infrastructure is always vulnerable. The growing incidence of multiple hazards. So you have, droughts and heats and extreme rainfall and sea level rise, cyclones and sea level rise, and so on. Aging infrastructure again, and furthermore, there is a trend of increasing intensity and frequency of extreme weather events such as heavy rainfall, large tropical cyclones, fires, and droughts. Okay, so I won't read all these details, but NOAA has made several moves into a seamless suite of models. Idea was to do weather and climate predictions together, and this is not as easy as you would think. Weather models and numerical weather prediction has gone off on its own for a long time, has a longer history as well. Just because it's easier to do weather forecasts in terms of not having a coupled ocean atmosphere system, the ocean can be prescribed, because the idea is during the weather time scale the ocean doesn't change so much, high heat capacity and all those nice things. But once you go beyond the weather time scales, then you need the ocean, because the memory of the ocean begins to play a role. And there are other entities like the National Academies of Sciences, Engineering and Medicine, which keep on producing reports on Earth system prediction, what the country needs to do, extreme events, what is the science, and so on and so forth. So let's just look at a figure here for the unified forecast system idea. Select members of the seamless suite of models used at the National Center for Environmental Prediction, NCEP, including deterministic and ensemble, extending from very short out to seasonal timescales and covering a range of phenomena. The UFS and EPIC support this range of timescales and forecast systems. So deterministic just means only one simulation is made. So if you're predicting weather, you make one model simulation, whereas to make it probabilistic, you use ensemble, so multiple realizations by perturbing the initial conditions and various other ways. But essentially you're trying to cover time scales going from minutes to years, so multiple seasons. And you have here warnings and alert coordination, watches, forecasts. So products and services on this axis extend to threat assessments, guidance and outlook. So longer term you want to give outlook, strategies, policies, etc. So long-term climate products currently utilized by NWS Climate Prediction Center here extend from the so-called extended range, so weeks 2 to 4, months, seasons and years. So the forecast uncertainty keeps growing as you go from minutes to years, and the short-term weather products utilized throughout the NWS National Weather Service sit here from minutes to a week or two. And then you have regional surface weather analysis, high resolution ensemble forecasts, hurricane analysis and forecast systems, the North American model, national weather model, rapid refresh ensemble forecast system, short range ensemble forecast system, global forecast system, whole atmospheric model, global ensemble forecast system, GFS, North American ensemble forecast system, climate forecast system, North American multi-model ensemble system. So you keep giving people more probabilistic information so that the action can be taken based on your tolerance. So airlines may need a different level of confidence than farmers, than insurance companies, and so on and so forth. Okay, so more words on how NOAA has taken an approach to simplification, unification, and community numerical weather prediction modeling starting in 2008, when actually NOAA invited the University Corporation for Atmospheric Research, or UCOR, to conduct a review of their national centers for environmental prediction. So a committee is put together when such an order is given, and committee of researchers from the academia, private sector, government labs, and so on, to put together evaluation, and then that helps make further improvements. So NOAA selected the NOAA Geophysical Fluid Dynamics Laboratory, for example, which developed a finite volume on a cubed sphere. So grid systems, how the dynamic or physics module is done, and so on, are all optimized in some way. So there is this R20 initiative, which I missed it somewhere, but it doesn't matter. I think it should be, anyway, it doesn't matter. I don't want to go into those sorts of details anyway. So we will keep, here it is, research to operations, so R2O, not R20, research to operations, R2O, which is very critical for a country like India as well, and I've been writing about it. With a lot of research going on focused on publications in academia, how do you bring it to India Meteorological Department, which makes the forecast with its labs? So how do you bring the research to operations? This is always tricky. The UFS is initially focused on Earth system prediction on shorter weather time scales as described in the definition above, but could be expanded to address environmental prediction challenges on longer time scales in the future. So what is Earth system prediction? The way I had interpreted it when I was leading a project on regional Earth system prediction was that we should be able to take the weather forecasts to applications for water, agriculture, fisheries, health, energy, transportation, buildings, and so on and so forth. Basically a suite of early warning early warnings for all these sectors, so that decisions can be taken to manage crises. So you want longer term forecasts for having an outlook here and guidance, and then threat assessments, and you want to take the forecasts and move them into watches and warnings and alerts and coordination. So on a seasonal level, you want to be ready for what's coming, and at shorter and shorter time scales, you have to move resources, move people, be ready to minimize impacts of unavoidable extremes or climate threats and hazards, and so on and so forth. Okay, so with that introduction, let's come back and continue this in the next podcast with a few more figures and more details. This will run into a few podcasts, I suspect, but it's worth doing it. It's very nice detailed paper which provides a nice framework that can be adopted by any country, and I'm, as I said, focused on seeing if India can also look at this and develop its own version of how things need to happen here on the subcontinent. Okay, so see you in the next podcast.